A very good day to all, and in this video we are going to deal with module 5 of power electronics, and this module is going to deal with electric drives. Now before moving on to the topic, you can see what you will be able to obtain or what is the course outcome of this particular topic. So at the end of this video series of module 5, you will be able to select converter and control schemes for AC and DC drive applications. So at the end of this electric drives topic, you will be obtaining or you will have attained the CO for number 4. Now, our module 5 is dealing with electric drives, and you can see the topics that are covered over here. And in this particular video, we are going to deal with the introduction to electric drives, and we will be completing the block diagram and the parts of electric drives. Now here we can see a block diagram of the electric drive. Before moving on to the block diagram of electric drives, we need to know first and foremost what is a drive. So a drive is any system that is employed for motion control. Okay, any system that is employed for motion control is called a drive. The motion control can be obtained by petrol engines or steam turbines or steam engines or electric motors. It can be obtained by anything. And if the motion control is specifically obtained by electric motors, then it is called a electric drive. Okay, if the speed control is or the motion control is obtained by electric motors, then it is called a electric drive. Okay, so I hope the term electric drive is clear. Now we can move on to the block diagram of the electric drive. So you can see over here, our aim is you need to provide motion for a particular load, and for that you have connected the load to a motor. For the motor to run, obviously you need to give it some kind of source. So you can see over here, from the source, the connection is not given directly to a motor. The connection is, it is connected through a power modulator. Okay, your source is connected through a power modulator. And the power modulator is placed over here so that it will convert the electrical energy into a form that is suitable for the motor. So what do you mean by that? Suitable for the motor. It simply means that I will explain it through an example. If your motor, suppose it is a DC motor and the source that is available at present is AC. So in that case, your power modulator is going to act as a rectifier, or your power modulator will be a rectifier. So what is a rectifier doing? A rectifier is converting the AC power to the DC power. And here you can see the proper energy conversion is being done by the power modulator. Okay, so the function, one of the function of the power modulator is to provide energy which is suitable for the motor. The second function of the power modulator is that suppose suddenly you are turning on the motor or you are turning off the motor, or maybe some kind of braking is taking place or acceleration is taking place. So you can see it is actually a transient condition. That means the motor was off and suddenly you are turning it on. Or maybe your motor was in the running condition, suddenly you are turning it off. So this is called a transient condition. So what happens during this transient condition? If the motor is off and you are suddenly turning it on, obviously there will be a high transient current entering the motor, or that may damage the motor. And in such situations, your power modulator will limit the amount of current flowing from the source. The amount of current flowing from the source to the motor will be limited by the power modulator. So as a summary, the power modulator is carrying out two functions. The first one is that it is converting it into a form suitable to the motor. The supply is being converted into a form suitable to the motor. Also, the currents are limited within the permissible range such that it will not damage our particular motor. So I hope it is clear what is the purpose of the power modulator. So you have a load and the motion control is being carried out by the motor, and the motor, instead of being directly connected to the source, it is connected through a power modulator, and the functions of the power modulator have already been discussed. And you can see over here, apart from this linear connection over here, we are also providing a feedback. You can see the feedback over here. From the output of the motor, we are connecting a sensor such that if you want to control the speed of the motor, or if you want to check whether the voltage provided is proper, or the current supplied is proper, or the speed. Basically, it's the speed because it is a motor is connected to the load. So you will connect a appropriate sensor over here, and the sensor will convert the particular signals into electrical signals, and it is given to a control unit, and the control unit will regulate the semiconductor devices present in the power modulator. Obviously, your power modulator will be consisting of semiconductor devices, and the operation of the semiconductor devices, that is when the switching on and switching off should take place, that will be, the signals will be provided by the control unit. So you can control the speed of the motor by simply providing a feedback. So this is the block diagram of our electric drive. And we can just see what are the main advantages of the electric drives. You can see over here, the electric drives are available in wide range of torque, speed and power. And electric drives have high efficiency. The no load losses are low. You can overload them for a short time, that's okay. And it is able to operate in any kind of most of the conditions, that is explosive or radioactive, because you are providing electrical energy, and it's not going to create any spark, and it's not going to create any explosion. You can submerge it in liquids. You can provide it in areas where vertical mounting is required. So all of these are not difficult if you are using electric drives. Then again, one of the obvious advantages, they do not pollute the environment. That is one of the main advantage. They can operate in all the four quadrants of speed and torque. Four quadrants of speed and torque means you can get positive torque and positive speed. You can get negative torque and positive speed. So all the four kinds of operation, four quadrant operations are possible. You do not need to refuel or warm up the motor. Obviously, it's simply electrical energy, and you just simply give the electrical energy, your motor starts to run. Refueling is not needed. You do not need to warm up the supply. It is powered by electrical energy. Electrical energy has a lot of advantages compared to the other forms of energy. That is, it can be petrol engines or steam engines. It has a very wide number of advantages compared to the other forms of energies. And the last advantage is that the speed can be controlled in wide limits, and you can provide electric braking, and you can use this braking energy, you can reuse the braking energy. Okay, this cannot be employed in other forms of drives. So these are the advantages of our electric drives, and you can just see the parts of the electric drives. Now your electric drive, we have already seen the block diagram. So you can see over here you are having 5 parts. You have a source, power modulator, motor, sensor and control unit. So you can see the same over here. You have a motor, you have a power modulator, you have a source, you have a load and you have a control unit. So these are the parts of the electric drives. Now moving on to the first one, that is the electric motor. You know that there are AC motors as well as DC motors. This is the broad classification. And initially we were using DC drives majorly, but then we saw that you can use AC drives also for applications, and this has led to a revolution. Okay, so we can just see what is the comparison between the DC drives and the AC drives. Okay, so DC drives, we know that the major component present in a DC drive or a DC motor is the commutator. And because of the commutator, you can see there are a lot of disadvantages. Okay, so the commutator is making the DC motor bulky, it's making it costly, it's making it heavy. You cannot provide good design, you cannot give proper ratings, and proper high speed cannot be obtained. Then frequent maintenance is required. So all of these are one of the disadvantages because of the presence of a commutator. And since AC drives do not have commutators, you can see they are not expensive. The speed and design rating do not have any limits, and they require less maintenance. So it can be used in all locations. Okay, if you are having DC drives, obviously the commutators will be providing some kind of sparks, and it cannot be used in all locations. Okay, so these are one of the drawbacks of using DC drives compared to the AC drives. But we can see that the power converters used for DC drives are simple and it's not costly. But the drives that are used for AC so the power circuits which are used for AC drives are more costly. Then you can see over here you have a small power to weight ratio, whereas here the power to weight ratio is large. Here you can obtain fast response irrespective of which type of control, but here you can see the response is depending on the type of control that you are using in the particular application. So according to our application, you can use DC drives or AC drives, but AC drives are more preferred. Now, in AC drives further, you can see there are more subdivisions. You have induction motors, you have synchronous motors, you have brushless DC motors, stepper motors, switched reluctance motors, and all of these you have already studied in synchronous and induction machine subject. Okay, so just to refresh what you have studied, you know that the permanent magnet synchronous motors and the wound field motors, they have a good efficiency, but the cost and size is high for the the permanent magnet motors are having high efficiency and power factor compared to the induction motors, but the maintenance is and the size is high for the same rating of the induction motors. And brushless DC motors is another type of motor. It is simple, it is cheap. That is also more commonly used in computer disk drives and servo drives. Then you have stepper motors. Okay, stepper motors is used for position control. Then you have switched in reluctance motors. Again, it is used for high power traction devices. Then that was all about the electric motors, and next we have to study about the power modulator. So you can just see a block diagram over here. So we had already explained about the power modulator according to our application. Okay, so if you have a AC supply and your motor is DC, so what do? You simply use a rectifier. If your supply is a DC supply and your motor is a DC, so do you need a converter? Yes, we need a power modulator. We do require a power modulator, because if you want to control the speed, you need to be able to vary the supply voltage. So in that case, you can use a chopper. Okay, so in that case, you can use a chopper. Okay, so you can see if you need a DC to DC conversion, you can use a chopper. And if your supply is DC, but you have a AC motor, so what do? You simply use a inverter. Okay, so in that case, you can simply use a inverter. And finally, if you have a AC supply and your motor is AC, yes, you do require a power modulator because you want to control the speed of the motor. So in that case, you use a AC voltage controller, or you use a cycloconverter, or you can use a matrix converter. So this is all about the power modulators. Okay, so we saw that a power modulator is usually placed between the supply and the motor. You can just go through this particular block diagram. Your power modulator is connected between the supply and the motor. So your power modulator can be any kind of particular converter circuit. And the next particular element that you have is the source. So the commonly used source we have is the single phase supply or the three phase supply that is available in India, and in India the frequency of supply available is 50 Hertz. In other countries the frequency range can vary, and the load requirement is not actually a part of the electric drives, but yes, according to our application, that is our load. Okay, then the final element or the final part that you have is the control unit and the sensor. Okay, so your control unit is providing the signals for the power modulator to operate. So the sensor will be sensing the speed variations, and accordingly it will give it to the particular control unit, and the control unit will convert the signals from the sensor into signals that can be processed by the particular power modulator, and the switching will be taking place according to the signals from the control unit. So we have dealt with the advantages of electric drives, the block diagram of electric drives, and the parts of electric drives in this particular video. I hope this video was helpful, and you can watch the next video that will be about the nature and classification of load torques. Thank you.